The temperature range of minus 160 degrees Celsius to 1,000 degrees Celsius is unique on the market and even allows the analysis of molten glass. Our Rio Compass software provides a spectrum of possibilities with countless measurement modes, 200 plus predefined templates, and top-level CFR 21 Part 11 compliance. 97% of all critical mechanical parts are manufactured in Austria in our in-house production facility. That means we also challenge the status quo of high-tech production chains. Evolution is a process where small, continuous improvements lead to a superior product. MCR was already the best. All the Evolution series means is the best just got better again.
Changes for some companies may be frightening. However, when the company manages to control fear, then it will be a tremendous energy to rise again. And Wika believes that. Being good is not enough. Wika must be great. Wika has represented itself as a state-owned enterprise, SOE, that first entered the foreign market before other contracting companies. This shows that Wika once again not only present, but help to carve a long history of development of Indonesia. Wika continues to try to find a new identity, which is better and more competitive and does not hesitate to reposition itself as a SOE that is ready to compete in the international arena. Wika believes that just being a leading company in the country is not enough. Then construction projects overseas are also rich. In addition, in the context of benchmarking, Wika wants to see and learn how the big companies overseas work. With these efforts, Wika expected then to be able to increase the network as well as strategic partners for strategic work at domestic and overseas. In developing overseas markets, Wika has done selective marketing strategies gradually. Wika enters a strategic in certain countries that are more comparative advantage compared to other countries. Wika focuses on international markets that have been controlled by itself. So far, Wika has reached the construction market in Africa, Southeast Asia, and has entered the Middle East market. In carrying out a project, Wika emphasizes the concept of cost, quality, and time. It means we have been trying to make every project that we work on has superior quality, without lack efficiency and effectiveness aspects. This is what makes us able to survive in the competition in the construction sector today. These values are unique and provide a strong and consistent platform to encourage every Wika resource in winning the competition, not only in the domestic market, but also in the international market.
3V geomatics analyzes radar satellite images that are acquired over time to inform our clients about any geohazards or risks that they have.
Essentially, what we do is take a satellite image, and a few days later or a week later, the same satellite will pass over again, take another image.
If we compare the two images, we are able to calculate whether the Earth's surface moves or not.
Very, very large areas can be monitored very effectively with INSAR technology.
Interferometric synthetic aperture radar, or INSAR, is a powerful technology for remotely detecting geohazards and protecting your assets.
With INSAR becoming more and more mature, there are more and more satellites that are going up.
3V Geomatics is the world leader in INSAR monitoring for the mining industry. Our technology informs our clients of subsidence, uplift, and other movements to help prevent environmental accidents, improve safety, and maintain operational success. Large areas are scanned at millimeter-level precision to assess an entire mine site. Open pits, tailings dams, infrastructure depots, and access roads can be captured in a single image without installing any equipment on site. By monitoring from above, INSAR covers blind spots in ground-based systems. Satellites pass overhead every few days, and data can be processed in hours, allowing for near real-time reporting. 3VG products can integrate with a range of software. In addition, we can work with our clients to support integration with existing systems on site. We have also built our own tools to allow you to visualize and analyze comprehensive report data in ArcGIS Desktop. INSAR monitoring is a cost-effective solution to reduce the risk of significant incidents and safeguard production. View and analyze your most up-to-date results online with Motionary. Gain context by viewing results in 3D with your own elevation model. Engineers can produce displacement graphs without any additional software or training. And your data is protected by enterprise-class security. Along with comprehensive tools and data, 3V Geomatics also offers the Rapid Report, a near real-time INSAR product. Through the years, we have refined and redeveloped this report to include both velocity and acceleration of displacement. Displacement risks are identified and measured across an entire mine site, providing early warning of changes for geotechnical staff. Data is provided in easy-to-use formats, allowing for rapid interpretation and mitigation. Since 2007, we have dedicated ourselves to developing and maintaining the best INSAR technology in the industry. We have extensive experience providing critical information that's tailored to the mining sector. 3V Geomatics, monitoring movement, mitigating risk.
The world is in motion. By the year 2050, there'll be more than 9 billion people on the planet Earth. 70% of them will be living in cities, and 80% of the products they consume will not be made or grown in their own country. So how do we make sure that the world stays in motion in the future? By taking a closer look at traffic and transportation as a whole, and developing integrated intermodal solutions for passenger transport and freight transportation, real-time solutions. After all, the world of tomorrow is networked. To ensure that goods arrive precisely where and when they are needed, routes must be strategically planned. With optimization tools from PTV, logistics operators can keep an eye on fleet efficiency and costs and always pick the most environmentally friendly route. To ensure that all road and rail users are treated fairly, cities and traffic planners must design urban infrastructures with maximum attention to details. This is where the planning and simulation tools from PTV can help. Will I be in time to catch the connecting service? What will the traffic situation be like in 10 minutes from now? Which is the quickest way to get to the city centre? PTV has the answers with innovative software solutions and consulting services for passenger transport and commercial carriers. From planning to implementation, we keep the world of the future in motion. Because we are the mind of movement.
Evolution is natural, a never-ending process of continuous change. Change that makes people and ideas even more successful, stronger, faster, smarter. Change that leaves the competition behind. Evolution is when pioneers set yet newer standards, raise the bar yet again. Evolution is when the best get even better. For Anton Parr, evolution means the next defining step in rheometry. The MCR Evolution Rheometer Series, consequent thinking and rethinking, decades of experience as the world market leader. More than 10,000 happy customers around the globe. Their feedback, the foundation of our new generation of rheometers. The result? A rheometer lineup incomparable to any other brand on the market. 15 rheometers, more than 200 accessories. The gold standard for custom rheological solutions for every application. The gold standard set by Anton Parr. MCR 302 and 702 are benchmarks in their segments. MCR 302 Evolution is the world's best-selling rheometer made even better. Optimized air-bearing EC drive, 40% faster system electronics, improved thermal management, and one-hand coupling, ingredients for success in challenging environments. MCR 702 Evolution Multi-Drive boasts the same advancements as the 302, plus the power of 2 drive units for the most sophisticated rheological research. Anton Parr was already pushing the limits in rheometry back when we invented the first EC permanent magnet synchronous motor. A new trimming mirror, a whole array of other features set the standard in instrument usability. The temperature range of minus 160 degrees Celsius to 1000 degrees Celsius is unique on the market and even allows the analysis of molten glass. Our Rio Compass software provides a spectrum of possibilities with countless measurement modes, 200 plus predefined templates, and top-level CFR 21 Part 11 compliance. 97% of all critical mechanical parts are manufactured in Austria in our in-house production facility. That means we also challenge the status quo of high-tech production chains. Evolution is a process where small, continuous improvements lead to a superior product. MCR was already the best. All the Evolution series means is the best just got better again.
Ladies and gentlemen, the opening ceremony is going to begin. So before getting started, let me go over to a little bit of housekeeping for the smooth running of this ceremony. First, make sure you have a stable connection of internet, and then please mute your microphone or mobile devices during the event. And the last, please kindly switch off or set any mobile device to silent mode throughout the event. And make sure you have stay in a convenient room. Thank you. Bismillahirrahmanirrahim. Excellencies, Insinyur Muhammad Basuki Hadi Mulyono, MSc PhD, Minister of Public Works and Housing of Republic of Indonesia, Honorable Dr. Andes Bejo So, MD PhD, Rektor Universitas Islam Sultan Agung, Semarang, Indonesia. Honorable Professor Datuk TS Dr. Ahmad Fauzi bin Ismail, Vice Chancellor of UTM. Respectable Professor Dr. Muhammad Ismit bin Muhammad Said, Pro Vice Chancellor International from UTM. Honorable Professor TS Dr. Ruzairi bin Abdul Rahim, Dean, Faculty of Engineering, UTM. Respectable Dr. Rahmat Mudiono, MT, Dean, Faculty of Engineering, UNISSULA. Respectable Professor Dr. Insinyur Slamet Imam Wahyudi, DEA, Head of Postgraduate Program Department of Civil Engineering, UNISSULA. Respectable Professor Dr. Nur Hazilan bin Muhammad Nur, Chair of School of Civil Engineering, UTM. Senior officers from UTM and UNISSULA, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning and very warm welcome to the opening ceremony of International Forum of Integrated Infrastructure Development, INFINID 2021. Ladies and gentlemen, first of all, let us extend our sincere gratitude to Allah Subhanahu wa Ta'ala, the Lord of the world, who has given us His blessing and mercy so that we can gather here. Praise and salutation upon our Prophet Muhammad Sallallahu Alaihi Wasallam, the last messenger, the best figure of this universe, who has carried us from the darkness to the lightness. Ladies and gentlemen, my name is Indah Setiawati, and it's a great honor to be your master of ceremony in this lovely occasion. Ladies and gentlemen, along the days, this year's conference will provide you plenty of opportunities to discuss, share knowledge and insight in today's International Forum of Integrated Infrastructure Development, INFINID 2021. Distinguished guests, ladies and gentlemen, we would like you to request you to all rise to precede this conference by singing the national anthem of the Republic of Indonesia. Please stand up. The national anthem of Malaysia. Himne UNISSULA. UTM Song, keunggulan terbilang.
Bersama kita menjulang keunggulan terbilang, kemaju jaya kita usaha UTM puncak letaknya, martabat keilmuan, cendekiawan beriman, cekal bersama takwa, menara cita-cita, kami anak kandung UTM ikut bernaung, usaha kami bukti cintamu, kikau pesona ilmu, keazaman, perjuangan pendidikan, penulisan perundingan, perkhidmatan kepada wadah. Di sini kami berdiri, setia pada janji, bermaruah berbudi bahasa. UTM sanjungan bangsa, UTM sanjungan bangsa.
Thank you and kindly be seated. Distinguished guests, ladies and gentlemen, without further ado, we would like to invite Bapak Ali Mustafa to deliver Al-Quran recitation. Please welcome.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إن في خلق السماوات والأرض واختلاف الليل والنهار واختلاف الليل والنهار لآيات لأولي الألباب الذين يذكرون الله قياما وقعودا وعلى جنوبهم وعلى جنوبهم ويتفكرون في خلق السماوات والأرض ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار صدق الله العظيم. Assalamualaikum warahmatullahi wabarakatuh.
Tova, may the Al-Quran recitation makes our soul fully charged spiritually, and may Allah bless this fruitful conference. Amin. Distinguished guests, ladies and gentlemen, now we would like you to invite the chairman of ICCDA 2021, Professor Dr. Insinyur Slamet Imam Wahyudi, DEA, to give welcoming speech and opening remark. Ladies and gentlemen, please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asrofil anbiya'i wal mursalin. Sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Amma ba'du. Excellency Insinyur Basuki Hadimulyono, Master Science PhD, Ministry of Public Works and Housing, Republic Indonesia, and also the first lecturer in Magister Civil Engineering UNISSULA in years 2000. Bapak Basuki is the UNISSULA, part of UNISSULA development and history. Excellency Professor Dr. Tun Sri Dr. Ahmad Fauzi bin Ismail, Vice Chancellor or Rector of Universiti Teknologi Malaysia. Excellency Associate Professor Bejo Santoso, PhD, Rector Universitas Islam Sultan Agung. Honorable Pro Vice Chancellor International Universiti Teknologi Malaysia, Profesor Dr. Muh Ismit bin Muh Said. Honorable Representative of Rotterdam University Applied Sciences, Professor Rick Heikop. Representative of Han University Applied Sciences, Groningen, the Netherlands, Professor Floris Bogart. Honorable Professor T.S. Dr. Rusairi bin Abdul Rahim, Dean of Engineering Faculty, UTM. Respectable, Honorable Insinyur Rahmat Mudiono, PhD, Dean of Engineering Faculty, UNISSULA. Respectable Committee of GEOTROPIKA and ICHITRA, Bu Dr. Heti and Bu Dr. Nur Hidayah. The distinguished guests and the participants, ladies and gentlemen. Welcome to the International Forum on Integrated Infrastructure Development, INFINID 2021. The forum consists of integrated 3 international conferences. The 12th International Conference of Geotechnical Engineering in Tropika region, GEOTROPIKA, the second International Conference on Highway and Transportation Engineering, ICHITRA, and the fourth International Conference on Delta and Coastal Area, ICCDA 4. Due to global health issue of COVID-19, INFINID 2021 is being held in hybrid mode, offline and online. The conference have two keynote speakers, Bapak Basuki Hadimulyono, PhD, Ministry of Public Work and Housing, Republik Indonesia, and Professor Floris Boga from Han University Applied Sciences, Groningen, the Netherlands. And we will present three invited speakers, Dr. Rinda Kalinasari from UNISSULA, Associate Professor Dr. Hayati Jacob, and Associate Professor Dr. Kamaluddin from UTM. And in total, there are 90 papers will be presented in the conference, in the parallel session. 23 papers in Geotropika, 30 papers in ICHITRA, and 36 papers in ICCDA. The paper will be continued to publish in IOP Earth and Environmental Science, that's indexed by Scopus, and also some journal from UTM or UNISSULA as well. I like to inform you that we will deliver Best Paper Award and Best Presenter Award for each session. For all presenters, do your best and catch the award. And last but not least, I would like to thank Universiti Teknologi Malaysia to nice cooperation organize this conference, and supported by Rotterdam University and Hans University, sponsored by from Malaysia and Indonesia, that will present also the sponsor in this day. And our shareholders for continuing to support us. May the conference run smoothly and goal will be achieved. That is all speech I can deliver. Thanks for your attention. My best wish to you all. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Professor, distinguished guests, ladies and gentlemen, now please join me to welcome Vice Chancellor of Universiti Teknologi Malaysia, Professor Datuk TS Dr. Ahmad Fauzi bin Ismail, to give welcoming speech. Please welcome Professor Datuk TS Dr. Ahmad Fauzi bin Ismail.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and greetings to all. Thank you, Master of Ceremony. To the Honorable Dr. Bijo Santoso, Rector, Universiti Islam Sultan Agung, UNISSULA, Indonesia. Associate Professor Dr. Muhammad Ismit bin Mat Said, Pro Vice Chancellor International, Universiti Teknologi Malaysia. Professor T.S. Dr. Ruzairi bin Abdurrahman, Dean, Faculty of Engineering, UTM. Ayah Rahmat Mudiono, Dean, Faculty of Engineering, UNISSULA. Professor Dr. Nur Hazilan bin Muhammad Nur, Head of School of Civil Engineering, UTM. Professor Dr. H.S. Imam Wahyudi, Head of Postgraduate Program, Department of Civil Engineering, UNISSULA, senior officers from UTM and UNISSULA, ladies and gentlemen. First and foremost, I would like to congratulate and thank both parties for their initiative and commitment in making this international conference a success during this challenging time, especially in facing the pandemic of COVID-19. I'm privileged and honored to be here to deliver this opening speech in my capacity as the Vice Chancellor of University Teknologi Malaysia. As we know, the collaboration between both parties has started since 2020. Since then, several academic activities and research collaboration between these two institutions have been successfully organized, specifically in the engineering fields with the involvement of the industrial partners. In addition, I have been informed that several civil engineering academicians at UNISSULA are UTM alumni. Such bonding has led to these joint conferences, namely the SWEF, GEOTROPIKA, Geotechnical Engineering in Tropical Region, second ICHITRA, that is International Conference in Highway and Transportation Engineering, and the fourth International Conference on Delta and Coastal Areas, ICCDA 4th, 2021. I believe this collaboration is a strategy to cater for the needs of Industrial Revolution 4.0 or IR 4.0, science, technology, and innovation combined with the transformation of Sustainable Development Goal implementation in higher education institution. This is part of the United Nations program for the year 2030 to support the specific agenda in the world in 2050, TWI 2050. Ladies and gentlemen, with the aid of fourth industrial revolution, sustainable modern technology has brought about huge impact, especially in the transformation of big data, Internet of Things, and blockchain, which has led to this collaboration. This collaboration should be regarded as a platform for participants to discuss and exchange ideas and knowledge in the related fields. The digitalization and digitizations can help in the existing education businesses, especially in research and innovation, as this approach is able to scale and disseminate information and knowledge efficiently. Emerging business models are allowing technologies to be dispersed globally and thus generating positive impact on the SDGs. The key points of this collaboration can be highlighted into 5 initiatives. Number 1, research and development. Number 2, curriculum formulation. Number 3, student engagement. Number 4, BIM, ready graduate. And number 5, knowledge sharing for industry, academia. With this, I do hope that we are able to learn from each other and could adopt some of the ideas to further improve our work and future needs. Since this is the digital era, this initiative can be further enhanced by providing shared access to online databases, training materials, and other relevant resources. Ladies and gentlemen, I would also like to urge both parties to utilize the current cutting-edge technology to ensure future success. One way forward is to explore synergies and complementarities between both parties to further strengthen the collaboration efforts between both teams. I would like to once again congratulate everyone in making this event a success. Lastly, I hereby officially declare the International Forum on Integrated Infrastructure Development between University Teknologi Malaysia and Universitas Islam Sultan Agung open. Thank you. Kerana Tuhan untuk manusia. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor. Distinguished guests, ladies and gentlemen, now we would like to invite the Chairman of GEOTROPIKA 2021, Dr. Nur Zurairah Hatti binti Muhammad Yunus, to give welcoming speech. Please welcome Dr. Nur Zurairah Hatti bin Muhammad Yunus.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Thank you, Master of Ceremony. To the Honorable Dr. Bejo Santoso, Rektor Universitas Islam Sultan Agung, Semarang, Indonesia. Yang berbahagia, Profesor Datuk Dr. Ahmad Fauzi bin Ismail, Vice Chancellor, Universiti Teknologi Malaysia. Respectable Associate Professor Dr. Muhammad Ismit bin Mat Said, Pro Vice Chancellor International, Universiti Teknologi Malaysia. Honorable Professor Dr. Ruzairi bin Abdul Rahim, Dean Faculty of Engineering, Universiti Teknologi Malaysia. Honorable Insinyur Dr. Rahmat Mudiono, Dean Faculty of Engineering, UNISSULA. Respectable Professor Dr. Insinyur Imam Wahyudi, Head of Postgraduate Program, Department of Civil Engineering, UNISSULA. Respectable Professor Dr. Nur Hazilan bin Makno, Chair of School of Civil Engineering, Universiti Teknologi Malaysia. Ladies and gentlemen, first and foremost, I would like to express my sincere appreciations to Universiti Teknologi Malaysia and Universitas Islam Sultan Agung UNISSULA from Indonesia, who generously worked to make this event become a success with the transitioning to virtual and hybrid formats during the current global crisis, pandemic, and beyond. A big thank you to everyone that has participated in International Forum on Integrated Infrastructure Development, INFINID 2021. It is my great pleasure to welcome all of you to our INFINID 2021 virtually. For your information, INFINID 2021 has been developed as a virtual conference that consists of 3 parallel conferences, which are the 12th International Conference on Geotechnical Engineering in Tropical Regions, GEOTROPIKA, the 2nd International Conference on Highway and Transportation Engineering, ICHITRA, and the 4th International Conference on Delta and Coastal Area, ICCDA for 2021. These conferences cover more than 30 scopes and involve many experts, especially from the fields of civil engineering, which include geotechnical, highway and transportation, and coastal engineering. As our themes for these conferences are Foster Future Through Geotechnical, Sustainable Engineering and Technology, Empower Transportation Engineering for Industrial Solutions, and Develop Engineering Contributions towards Coastal and Delta Area. Development. INFINID 2021 has also been created with 2 combinations of among the best universities in Malaysia and and Indonesia, UTM and UNISSULA respectively. Alhamdulillah, today our partner from UNISSULA will organize our conference opening in Semarang, Indonesia. From this virtual global gathering, I am encouraging all of you to look forward to our successful and great panel of speakers. Sharing with you their experience and knowledge during the keynote session. In addition to that, we hope that by gathering all participants, we are able to present the recent research trend in civil engineering, especially in geotech. Technical, highway and transportation, and coastal engineering. Fields. Monitor current developments in technology and expertise. related to civil engineering at the international level, able to search for
Engineering of Universiti Teknologi Malaysia UTM, Hans University of Applied Sciences and Rotterdam University of Applied Science Netherlands. Also, we hope that this international conference can run very well and benefit to entire communities, good nationally and internationally. The three main fields are chosen with some particular reasons, with concern on the academic work about the importance of research development and strengthening of knowledge and technology in order to foster and empower various disciplines in the three areas. To tackle the global issues, it is important that scientists, researchers, practitioners, and scholars around the world gather, sitting together in the one place by discussing and find the best solution. That's why we have this INFINID 2020. We can use this seminar as medium to discuss for the solution and understanding the problem and what is the solution that we face now. By far, we will share our knowledge, researchers, best practices, and update condition and issues, will become our objective, and how this condition will directly touch the joint in of our life that require various kind of the best alternative solution in the geotechnical, transportation and highway, and coastal area as well, where every single thing in this area matters. The key point or topic we hope could be discussed in the big copter, in the big frame, from 4 main issues. Now, number 1, from big data perspective. Number 2, Internet of Things, IoT perspective. Number 3, artificial intelligence perspective. And lastly, blockchain perspective. The fourth thing, I think, is very important issue, because now we live in 4.0, even some scholars say 5.0 disruption. Everything is digitally, everything is technology, ICT. Furthermore, INFINID is a place for national and international academic to meet and present their research while exchange information and sitting together. But we hope not just sitting together. I hope, as the rector of UNISSULA, I hope this event will be continue in the working together. Because sitting together is just beginning, but working together is a progress. I believe this international forum will provide a lot of engineering contribution, especially in the coastal and delta area development, transportation problem, industry, geotechnical, and sustainable engineering, and also technology for future generation that we are going to base together. At last, we would like to especially express our gratefulness to the leader of Faculty of Engineering UTM, Vice Chancellor of UTM, Hans University, Rotterdam University, and another sponsor. We also we also thank to all presenters, participants, committees, and sponsors who have tried to make INFINID a huge success for sharing knowledge and sharing method and find the solution. Inshallah, Allah will bless us by good deed. This good deed blessed by Allah Subhanahu wa Taala as our sharing to the society. Finally, we would like to end up the speech by saying the pantun. Pulau Pandan jauh di haluan, bersinarlah pulau angsanan dua. Walau kita saling berjauhan, seminar ini tetaplah jaya. Beli pala di tanah Melaka, digarami bersama di negeri Mamiri. Hari ini kita gembira bahagia, sebab bersama ada Pak Menteri Basuki. Wabillahi taufiq wal hidayah wal afu minkum. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Bejo Santoso. Ladies and gentlemen, now let's see the montage of UNISSULA and UDM.
Hi, I'm Dr. Ismail, broadcasting from Kajang, Selangor, Malaysia. I would like to congratulate the organizing committee for this year's GEOTROPIKA. I was associated with GEOTROPIKA as the chairman for GEOTROPIKA 1994, third GEOTROPIKA in Malacca. Thank you for continuing these GEOTROPIKA conferences and hope that GEOTROPIKA conferences will serve our fraternity, geotechnical and transportation engineering. Have a nice conference in Malang, and hopefully we'll be able to meet each other again in the future. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Di kesempatan ini, saya ingin mengucapkan selamat datang dan terima kasih kepada para peserta INFINID 2021 yang merupakan gabungan GEOTROPIKA, ICHITRA dan ICCDA. Tahniah saya ucapkan kepada para ahli jawatankuasa pelaksana kerana berjaya merealisasikan joint conference di antara UTM dan UNISSULA ini. Semoga jaringan hubungan di antara kedua-dua universiti ini akan sentiasa erat dan berkekalan. Akhir kata, saya ingin mengucapkan selamat maju jaya dengan harapan conference ini menjadi satu platform perbincangan ilmu serta dapat memberi manfaat kepada semua. All the best, INFINID 2021.
Hello, hi everyone. I'm Aminata Marto, one of the founder of GEOTROPIKA when we start in 1990. At that time, I was the first secretary of the GEOTROPIKA, which was a regional conference. And in 2010, I was made the 8th chairman of the GEOTROPIKA and also ICHITRA when we organized it successfully in Kota Kinabalu, Sabah. And I hope that you make connection between each other so that there'll be good networking in terms of doing research together and co-authoring writing papers. I wish I'll be with you all, but probably I won't be there because of my health. Thank you very much, and I hope you will enjoy the conference.
Assalamualaikum and hi everyone. My name is Dr. Muhammad Rosli bin Hainin. I was the chairman for the 9th GEOTROPIKA that was held in Johor Bahru in 2013. I would like to say thanks to everyone who participated in this conference and I hope you all can benefit most out of this conference. Thanks.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. It's a wonderful pleasure for me to welcome all participants to INFINID 2021. This is a special occasion where GEOTROPIKA, ICHITRA and ICCDA are jointly organized as a sign of long, harmonious collaboration between UTM and UNISSULA. In this opportunity, I would like to congratulate all the committee members for making this event a great success. To all participants, I would like to thank you for supporting our conference and hope you will gain great benefits from this academic discourse. Have a great conference.
I am Kamaruddin Ahmad, the chairman of the 11th GEOTROPIKA. Thank you for your participation in this 12th GEOTROPIKA despite the global COVID-19 pandemic.
Assalamualaikum and hi everyone. My name is Professor Dr. Muhammad Rosli bin Hainin. I was the chairman for the first ICHITRA conducted in UTM KL back in 2019. Thanks for keep on supporting our conference. I hope we can get the most out of this conference. Thank you.
Okay, distinguished guests, ladies and gentlemen, now before we are going to the keynote speeches, we will have the photo session via Zoom. So I request to all participants, please kindly have your camera on due to the photo session. Okay, for the multimedia, maybe you can have. So how many participants we'll have here? Okay, I will count 1, 2, 3. Oh, wait. Okay, so we will wait until everybody or all pictures appear on screen. Okay, start now. Again, at the next screen. Okay, the third screen. The next. Okay, thank you very much. Distinguished guests, ladies and gentlemen, now we are about to have the keynote speeches of INFINID 2021. It's now my deep pleasure to introduce the first keynote speaker today, Minister of Public Works and Housing of Republic of Indonesia. Insinyur Muhammad Basuki Hadi Mulyono, MSc, PhD, born 5 November 1954, is the Minister of Public Works and Housing in President Joko Widodo's Advanced Indonesia Cabinet since 23 October 2019. Previously, he also served as Minister of Public Works and Housing in the Cabinet of President Joko Widodo and Vice President Yusuf Kala for 2014 to 2019 period. Insinyur Muhammad Basuki Hadimulyono, MSc PhD, took his engineering degree from Gajah Mada University and earned his master and doctorate degree at Colorado State University, USA. Basuki is a diligent, smart, and hard worker, and he really started his career from the scratch as a civil servant. Ladies and gentlemen, please welcome His Excellencies Insinyur Muhammad Basuki Hadi Mulyono, MSc PhD.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, distinguished guests. Honorable Director of Islamic University of Sultan Agung, Semarang, Excellency Mr. Bejo Santoso, PhD, distinguished speakers, experts, guests, ladies and gentlemen. It is indeed a great pleasure and an honor for me to join all of you here this morning on the International Forum on Integrated Infrastructure Development 2021 held by the Islam University Sultan Agung, to the committee of organizing this virtual conference. Even though now we meet in the virtual mode, but I can still feel the spirit of silaturahim between us. Ladies and gentlemen, President Joko Widodo has set infrastructure development as a main priority amongst 5 main directions for 2020-2025 as part of the vision of Indonesia Maju, like infrastructure development, human resources development, deregulations and debureaucratization, and the economic transformation, because we realize that infrastructure development has several important roles, such as improving civilization, increasing competitiveness, assuring social justice, especially for the Indonesian as archipelago country, and strengthening national unity. To achieve inclusive security on water, food, and energy nexus in the period of 2020-2024, the Ministry of Public Works and Housing set to construct at least 61 dams, revitalize 500 reservoirs and lakes, rehabilitate 2 million hectares of irrigation system, and develop 500 hectares of new irrigation system. In our new and existing dams, we are going to in-depth elaboration of the potential development of new and renewable energy, particularly in the forms of hydropower and the provision of space for solar panels. The hydropower installation draw their potential energy for the dams that have been designed initially as multi-purpose dams. The completion of 61 dams will increase water for irrigation system that now we have 11%, improve to 20% to irrigate more than 7.2 million hectares of irrigation system. So before we have now the existing, we have 231 dams that serve 11% of the irrigation system. But after we build 61 dams that will be finished in 2024, it will increase the surface of irrigation into 20%. It means that by increasing the availability of irrigation water, we can improve, we can increase planting intensity for 1 time a year as a rainfed area 2 times or 3 times 2 years for irrigation planting. To make our cities and our human settlements more livable, safer, and at the same time less vulnerable to climate change, slum area upgrading projects have also been implemented. In line with this, we have constructed more green buildings, flood protection facilities, developed open green spaces, implemented water quality of water supply and sanitation schemes. We also developed programs to reduce and manage solid and liquid waste in urban and rural areas. Ladies and gentlemen, to protect, restore, and promote sustainable use of our environment and ecosystem, the Ministry of Public Works and Housing has done its best to make into account environmental preservation and ecosystem harmony in every phase of design, construction, operation, and maintenance activities. We use the tagline SIT-LACOM, survey, investigation, design, land acquisition, construction, and operation maintenance in every step of infrastructure development under the Ministry of Public Works and Housing. Recently, the Ministry of Public Works and Housing has been undertaking programs of lakes, rivers, and catchment area conservation. In this regard, we work closely with the Ministry of Environment and Forestry to identify and reduce the potential negative impacts on the environment. It's also important to realize that Indonesia has about at least 10.8 million hectares of swamp areas, which have huge potentials, and it is very important to preserve them for our future generation. As you can watch in the screen, it is in central Kalimantan, in the swampy area, but not gambut area. Okay, this is in the alluvial area of swamp environment. Ministry of Public Works and Housing has undertaken construction and rehabilitation of some irrigation networks in central Kalimantan in way that comply the principle of sustainability. Infrastructure development does not stand alone, but it must be linked to development of productive areas, such as metropolitan cities, industrial areas, tourism areas, ports and airports to improve logistic connectivity. For example, the Trans-Sumatera Toll Road, which connects industrial area with ports, including the Lampung Industrial Park area with Panjang Port, Lampung, and Bakauheni. The Trans-Java Toll Road, and on the other hand, is built to support the connectivity of industrial area in Java, including Geotropika, Kerawang, and Subang Industrial Area in West Java, and Batang Industrial Area in Central Java. Ladies and gentlemen, apart from that, we currently undertaking toll road development in north coast of Central Java between Semarang and Demak, which also function as a sea dikes through the public-private partnership scheme. Hopefully, this can solve the tidal flood problem which can occur. Our ministry also encourages innovation in infrastructure development. Innovation provides added value and more human side to every infrastructure built. It is where a solid structure will blend with its main function and supported by aesthetic elements. For this reason, I really appreciate the science innovation made in infrastructure development. It is also implemented building information modeling, or BIM. It is now popular in in construction industry, on several infrastructure projects such as the construction of Johar Market in Semarang, Sports Stadium in Solo and Papua, in a dam, Sindangla Dam in Banten, Manado Bitung Toll Road in North Sulawesi, and Kendari Bay Bridge in Southeast Sulawesi. The existence of BIM technology will continue to be expanded because it greatly supports speed, flexibility, and accuracy in the planning, implementation, supervision, and even in the auditing processes. By using BIM, infrastructure development is upgraded to a higher quality. To conclude, I highly appreciate this kind of scientific meeting and conferences, which is very important to bring academic community, scientists, researchers, and practitioners to meet and discuss today's situation, as well as prepare for the future challenges of infrastructure development. I sincerely hope that this conference will generate new great ideas, identify and elaborate new initiatives needed, and promote collaborative action for integrated infrastructure development. I wish you all a great and fruitful discussion during the conference. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Insinyur Muhammad Basuki Hadimulyono. What an enlightening speech. Ladies and gentlemen, before we are going to the next keynote speech, now we will have a commercial break.
The world is in motion. By the year 2050, there'll be more than 9 billion people on the planet Earth. 70% of them will be living in cities, and 80% of the products they consume will not be made or grown in their own country. So how do we make sure that the world stays in motion in the future? By taking a closer look at traffic and transportation as a whole, and developing integrated intermodal solutions for passenger transport and freight transportation, real-time solutions. After all, the world of tomorrow is networked. To ensure that goods arrive precisely where and when they are needed, routes must be strategically planned. With optimization tools from PTV, logistics operators can keep an eye on fleet efficiency and costs and always pick the most environmentally friendly route. To ensure that all road and rail users are treated fairly, cities and traffic planners must design urban infrastructures with maximum attention to details. This is where the planning and simulation tools from PTV can help. Will I be in time to catch the connecting service? What will the traffic situation be like in 10 minutes from now? Which is the quickest way to get to the city centre? PTV has the answers with innovative software solutions and consulting services for passenger transport and commercial carriers. From planning to implementation, we keep the world of the future in motion. Because we are the mind of movement.
Evolution is natural, a never-ending process of continuous change. Change that makes people and ideas even more successful, stronger, faster, smarter. Change that leaves the competition behind. Evolution is when pioneers set yet newer standards, raise the bar yet again. Evolution is when the best get even better. For Anton Parr, evolution means the next defining step in rheometry. The MCR Evolution Rheometer Series, consequent thinking and rethinking, decades of experience as the world market leader. More than 10,000 happy customers around the globe. Their feedback, the foundation of our new generation of rheometers. The result? A rheometer lineup incomparable to any other brand on the market. 15 rheometers, more than 200 accessories. The gold standard for custom rheological solutions for every application. The gold standard set by Anton Parr. MCR 302 and 702 are benchmarks in their segments. MCR 302 Evolution is the world's best-selling rheometer made even better. Optimized air-bearing EC drive, 40% faster system electronics, improved thermal management, and one-hand coupling, ingredients for success in challenging environments. MCR 702 Evolution Multi-Drive boasts the same advancements as the 302, plus the power of 2 drive units for the most sophisticated rheological research. Anton Parr was already pushing the limits in rheometry back when we invented the first EC permanent magnet synchronous motor. A new trimming mirror, a whole array of other features set the standard in instrument usability. The temperature range of minus 160 degrees Celsius to 1000 degrees Celsius is unique on the market and even allows the analysis of molten glass. Our Rio Compass software provides a spectrum of possibilities with countless measurement modes, 200 plus predefined templates, and top-level CFR 21 Part 11 compliance. 97% of all critical mechanical parts are manufactured in Austria in our in-house production facility. That means we also challenge the status quo of high-tech production chains. Evolution is a process where small, continuous improvements lead to a superior product. MCR was already the best. All the Evolution series means is the best just got better again.
Changes for some companies may be frightening. However, when the company manages to control fear, then it will be a tremendous energy to rise again. And Wika believes that. Being good is not enough. Wika must be great. Wika has represented itself as a state-owned enterprise, SOE, that first entered the foreign market before other contracting companies. This shows that Wika once again not only present, but help to carve a long history of development of Indonesia. Wika continues to try to find a new identity, which is better and more competitive and does not hesitate to reposition itself as a SOE that is ready to compete in the international arena. Wika believes that just being a leading company in the country is not enough. Then construction projects overseas are also rich. In addition, in the context of benchmarking, Wika wants to see and learn how the big companies overseas work. With these efforts, Wika expected them to be able to increase the network as well as strategic partners for strategic work at domestic and overseas. In developing overseas markets, WIKA has done selective marketing strategies gradually. WIKA enters a strategic in certain countries that are more competitive advantage compared to other countries. WIKA focuses on international markets that have been controlled by itself. So far, WIKA has reached the construction market in Africa, Southeast Asia, and has entered the Middle East market. In carrying out a project, WIKA emphasizes the concept of cost, quality, and time. It means we have been trying to make every project that we work on has superior quality, without lack efficiency and effectiveness aspects. This is what makes us able to survive in the competition in the construction sector today. These values are unique and provide a strong and consistent platform to encourage every WIKA resource in winning the competition, not only in the domestic market, but also in the international market.
3D geomatics analyzes radar satellite images that are acquired over time to inform our clients about any geohazards or risks that they have.
Essentially, what we do is take a satellite image, and a few days later or a week later, the same satellite will pass over again, take another image.
If we compare the two images, we are able to calculate whether the Earth's surface moves or not.
Very, very large areas can be monitored very effectively with INSAR technology.
Interferometric synthetic aperture radar, or INSAR, is a powerful technology for remotely detecting geohazards and protecting your assets.
With INSAR becoming more and more mature, there are more and more satellites that are going up.
3V Geomatics is the world leader in INSAR monitoring for the mining industry. Our technology informs our clients of subsidence, uplift, and other movements to help prevent environmental accidents, improve safety, and maintain operational success. Large areas are scanned at millimeter-level precision to assess an entire mine site. Open pits, tailings dams, infrastructure depots, and access roads can be captured in a single image without installing any equipment on site. By monitoring from above, INSAR covers blind spots in ground-based systems. Satellites pass overhead every few days, and data can be processed in hours, allowing for near real-time reporting. 3VG products can integrate with a range of software. In addition, we can work with our clients to support integration with existing systems on site. We have also built our own tools to allow you to visualize and analyze comprehensive report data in ArcGIS Desktop. INSAR monitoring is a cost-effective solution to reduce the risk of significant incidents and safeguard production. View and analyze your most up-to-date results online with Motionary. Gain context by viewing results in 3D with your own elevation model. Engineers can produce displacement graphs without any additional software or training. And your data is protected by enterprise-class security. Along with comprehensive tools and data, 3V Geomatics also offers the Rapid Report, a near real-time INSAR product. Through the years, we have refined and redeveloped this report to include both velocity and acceleration of displacement. Displacement risks are identified and measured across an entire mine site, providing early warning of changes for geotechnical staff. Data is provided in easy-to-use formats, allowing for rapid interpretation and mitigation. Since 2007, we have dedicated ourselves to developing and maintaining the best INSAR technology in the industry. We have extensive experience providing critical information that's tailored to the mining sector. 3V Geomatics, monitoring movement, mitigating risk.
Okay, ladies and gentlemen, see you again. Now we would like to warmly invite the second keynote speaker, Dr. Floris Bogaert, PhD from Hans University of Applied Science, the Netherlands, and the invited talk, Dr. Insinyur Linda Karlinasari, MD for Universitas Islam Sultan Agung, Indonesia. And this session will be chaired by Mr. Ari Sentani. So I will pass the microphone to the moderator, Mr. Ari Sentani. The time is yours.
Thank you, Mr. Indah. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome to INFINID 2021. We are pleased to have you join us for the keynote speech of INFINID 2021 and to take part in today's session. First, let me introduce myself. My name is Ari Sentani from UNISSULA. In order to be considerate and respectful to everyone attending and presenting today, all attendees are muted. We will have designated time to address questions, but you may submit questions at any time during the session. To submit a question to our panelists or to our speaker, please enter your question in the Q&A text box. Kindly write it in the chat box. And now I'm pleased to introduce Professor Floris Bogaert. He's a professor of special transformation, senior consultant, and researcher. He has 25 years experience in research and consultancy in international climate adaptation. His projects integrate the worlds of spatial planning and water management with a focus on the implementation of nature-based solution and sustainable urban drainage system. Forrest Bogart accepted a professorship special transformation at the School of Architecture, Built Environment and Civil Engineering at Hensey University of Applied Science in Groningen in 2013, working on urban climate adaptation around the world in close relation with other universities, including UNISSULA. Police Bogart is currently a consultant water and subsurface at Deltares and an affiliate researcher at the Global Center of Adaptation that accelerates climate adaptation by recognizing, building, and promoting excellence among all relevant stakeholder groups around the world. His general research and advice fields include climate adaptation, stormwater drainage and infiltration, river rehabilitation, complex monitoring, and urban water quality management. And now, Mr. Flores will deliver his speech. Please, Mr. Flores, the time is yours.
Hello, everyone. Thank you, of course, for inviting me to this conference. I'm really excited to talk about international knowledge exchange on climate adaptation with a focus on integrated infrastructure development. It's very nice to see so many great speakers in the program. I'm very glad that from the Hanze University of Groningen, which is in the Netherlands, we could be part of the organization as a collaborator. So what is very difficult, of course, with a keynote is this is such a great conference. There's so many topics. It's so multidisciplinary. So what do you choose as a topic that could address anyone? I choose knowledge exchange, international knowledge exchange, being from the Netherlands. But maybe I should introduce. I'm a professor at Groningen, which is high up in the Netherlands, below sea level, by the way. I'm also an affiliated researcher at the Global Center of Adaptation, and I also work at Deltares in this case. I do a lot of international projects. I will show something of that later. Maybe my unique selling point would be that all my jobs are below sea level. So if the dikes would break, I would probably look for a great position in Indonesia, of course. So, um, what what do I want to tell? I think, of course, let's start. This is one of the first presentations. So about the challenges, what to address with sustainable infrastructure. I want to show you very briefly about 101 projects on the international exchange, of course, and the partnerships there. Let's focus on solutions, and especially, do we learn from all these projects, from all these solutions? Where can we find these solutions when projects are finished? I think that's one of the key elements. As Friedrich Hegel said, we learn from history that we don't learn from history. And I think that's a very important point. And I want to address you, because what do you actually want, or how can you participate? So I'm going to be very practical. I'm going to show you two tools that you can use with partners, of course, but also on your own online. And I'm going to address the last parts with where can you find more info. But first, challenges. There are a lot of them. This is about climate adaptation, but because of course we have extensive rainfall, floodings. We have also drought, because water management in the cities could be a lot better. We have higher temperatures that will increase in the future. That has an effect also on the air quality, the water quality. So you can see a lot of pictures here that are, of course, addressing climate adaptation. But it's not only about climate adaptation. Cities as Jakarta are expanding more and more. So we need a new green infrastructure, for example, to save our lives with biodiversity, heat stress, and all those challenges that we have. So, of course, this is not new. We have also, what I didn't tell you is about if we have drought or groundwater extraction that could tap into a lower groundwater table and subsidence of cities, sinking cities, so to say. Jakarta is one. Of course, Rotterdam is one. A lot of cities actually in the Netherlands below sea level. So these are things that we can address. And I want to address some things that we can do, me from Holland, you from Indonesia or Malaysia, there where we can address these challenges and learn from each other. And of course, being in Indonesia, you can see by my shirt, a batik shirt from Semarang. Of course, I've been in Indonesia addressing some of these problems like water quality, as you can see here, batik on the right, the floodings, as you can see. Yeah, it's very appealing to me to do something about it and do knowledge exchange. Just going to show you some pictures, some of the projects here. It's about subsidence, lack of awareness, drought, ecology, yeah, and of course it's also about governance. It's also about social science. It's about technical science. So I'm really glad that we have this international conference. So enough about challenges. Then what can we learn from all these partnerships and the projects that we have? We're just going to browse through these pictures. Probably you recognize there's a lot of logos on it. There's projects from where I was involved with, from 2014, for example, all over Dutch newspapers, all over Indonesian newspapers, or Malaysia, or international, of course. It's about taking measurements. It's about communication. You see a lot of people that are getting training so they know how to analyze an area. It's about field trips. You see a lot of logos again with water authorities like Jasa Tirta. Again, going on boats, visiting the field sites, then disseminate all that knowledge on big congresses. And then you get in a newspaper, and then you have a different batik shirt, and then you have even more logos and people attending, and you talk about polder systems, for example, in Semarang, which is, some of the knowledge that we have in the Netherlands, of course, because it happened to us already 300 years ago, and even more exchange with universities. And we saw some pictures of water quality that could be better, to use an euphemism. And of course, it's about water quantity, it's about water quality, it's about fish almost dying maybe, and of course getting action, because we know the challenges. We just want to team up, as you can see in these pictures. We want to make living labs, so stakeholders are involved as well. We call it a triple helix, because education, research, partners from public and private entities should be involved. So basically, we have a lot of projects. But did we learn from them? That was quite fast, but I think you get the idea. So what can we learn from all these projects and partnerships that a lot of you were involved, and you could find yourself in the pictures, I think. But what can we learn? Well, basically, and that's a no-brainer, we start with analyzing the situation. So all these pictures that I've shown are, of course, the basis of analyzation, because it's not only about the technical analyzation that you can find here in rivers, and then you look for the ambition. You want clean water, for example, or fighting drought or floodings, but it's all about action. And it's very good that in the beginning, what you saw from all these pictures, it is action. It is action. You could say, okay, you talk a lot, but what do you do? Basically, it's about education. It's raising awareness. It's building trust and networks, because without that, you should not start with implementing measures or solutions in this case. So a first step is also capacity building. Train the trainer. And in those pictures, what you saw, you see people teaching, exchanging knowledge, and of course that's very, very, very important. And with climate adaptation, it's a big challenge. So be aware, and be also realizing that we have to get used to more intensive stormwater events, some floodings, and because we cannot solve everything. It's really out of our hands. We are taking over the earth at places that we shouldn't be. Maybe we're really taking over. So we should change stuff, and that's nice. But how do we adapt? How can we learn? What kind of projects are already out there? What does work? What are the best management practices in this case? What we find. And those are some tools that I want to show you. And these are some projects, and I'm just now focusing on the Netherlands, Indonesia, basically Asia, where you can find some of the inspiration that you might need. And then you can decide yourself if you find this attractive or that it's cost effective to implement in the city as well, anywhere in the world, basically. So if we address very tangible projects, one thing that I'm involved with, and is of course quite on a high agenda for a lot of partners, is if we talk about climate adaptation, it's about too much water, too less water. And if we make amphibious or floating infrastructure, it doesn't matter if it's too high because it will go up with the water, or if it's too low, it will just go to the land. So that's amphibious. If it stays in the water, it's floating. And there are a lot of Dutch examples, as you can see here on the left, floating homes in Amsterdam, our capital. And of course, we learned a lot from some of the projects that you have actually in Indonesia or Asia for that case, like floating solar panels, floating libraries, as you can see here. I had the privilege to be in a floating restaurant. It was very nice. So I think we change the infrastructure to be more sustainable. So we change from gray infrastructure maybe to floating infrastructure, more flexible infrastructure, and also green infrastructure. Because tapping into this, you see in cities, we have more asphalt, we have more paving. Green doesn't get any chance anymore as the trees here on the left. It seems like if a rainfall comes, it doesn't infiltrate to the ground anymore as in the old days. We used to prevent water from going in, and that of course taps into subsidence. That's why groundwater levels drop, because we pump it up. And I think this is an essential thing to go from gray infrastructure, which is mostly stormwater drainage, for example, we go to more green and green infrastructure, as these wonderful artists sketched here. So we have to open up pavement. We have to use green for storage of water, for infiltration. And that's not an easy task. Because if you look at pictures here, one is Sao Paulo on the right, and we have New York, Manhattan, you can see a lot of gray, and it's not integrated. So one of the things that we should do now is to make cities greener, to face climate adaptation. And here are some great examples around the world, but does it fit? If you are in Malaysia, can I implement this or not? And of course, there's so many technical implementations already around the world that can be very inspiring for you to see if this fits. And of course, it's totally different locations, it's totally different governance, but it can be used as inspiration. And that's why analyzing, forming your ambition, and action is very important. And don't wait for action after talking about analyzing your area and forming the ambition. It's very good to do that interactive. And I really hope that we can learn from mistakes that others make. Because even in the Netherlands, we had a lot of implementations of gray infrastructure. You know, you see the water quality, we have to use wastewater treatment plants, so big concrete structures, which are very expensive and need a lot of maintenance. And now we gather more information about nature-based solutions. Can we purify the water by using nature, which is sometimes more effective and also cost-effective because it has a higher removal efficiency rate sometimes. And it can also be used because this right picture that you might see here in the corner, you see people walking through a park. It's actually a wastewater treatment plant. So that can be very inspirational. And what I try to form here with this, we spend a lot of money to this. And having this knowledge, maybe we can have an Indonesian or Malaysian or Asian shortcut to effective solutions right away that will cost less time and less money. So nice, but what do you want to hear? What is essential for you? I'm just going to show you two tools, Climate Scan and Climate Cafe, and then I'm gonna leave again, of course, which might be essential for your use. And I'm just gonna go through it rapidly because it's easy for you to find more information. And it's based on some workshops I did with a lot of colleagues and partnerships, which you saw in the beginning in Indonesia, mostly in Surabaya and Semarang in this case. What did we find out? workshop results. It's all published. You will find publications later. We found that there is a very strong urge to need more information about green infrastructure and maybe bioswales, rain gardens, constructed wetlands in particular. And of course, there are already some of the implementations. And also the lessons learned from other countries, the success stories, what can we implement, has been harvested in these workshops that you can see here. So I focus a bit on this to end up my presentation. So one of the things, there are a lot of tools that you can use and be interactive. One of them is Climate Scan. It's one of the global climate adaptation networks or platforms that you can actually find. I'm going to focus on that. And there's a lot of materials that you could use. If you're interested in nature-based solutions, you probably know this document, and it shows that Climate Scan ticks a lot of boxes, even more boxes here, which you can find. But what is it? Climate Scan is a database that you can feed, that you can use for finding inspirational projects all around the world. It has over 6,000, actually over 7,000 already. It has over 1,000 registered users, a lot of them from Asia as well. And you can, with your app, you can upload a lot of from your projects that you want to share. And this is a tutorial, not going to show it, but if you're interested, you can provide your projects. So what's on there? Well, basically pages with videos like this, with very simple implementation that don't cost a lot of money and energy for you to use. Rain gardens on the right, some lower pavement on the left, which is quietly used. And who are those people around the world that actually are uploading things? Well, a lot of different people, as you can see here. And maybe focusing more on the Asian part, this is all the info you can find. So many projects around the world. There are a lot of pictures. You can see downloads. You can see research papers, which is interesting for me, of course, as a researcher. So you can look down to solutions, but also sometimes problem areas are mapped. For example, these aluminium ash is being used as a building material, and there's not a lot of knowledge on the effect of water quality, for example. So what does it do? It's multifunctional, yes, but has it an effect as an outlet, like a discharge from wastewater? Will it leach metals? It's not really known. And then, of course, we have to use maybe some purification, some basic purification principles, as you can see here. So, and these are some information, some projects from around the world that you can find here. A lot of actually Indonesian solutions already that are uploaded, probably by you or a colleague of you, on floating urbanization or bioswales or green roofs. And there's always like this link that you can find and find more info. And of course, I started up with all these projects from Connecting the World, being a solution broker that the Global Center of Adaptation does. So you can find these projects here and find more information and read about it. And it's not only a place on the map. It has also some data, water quality data, which is harvested by underwater drones that you saw. And this data can be used as researchers to analyze cities, Dutch cities, but also cities around the world like Copenhagen and Malmö and Johannesburg. And we're starting up to do analyzation of Asia now, to see what's already out there for cities, well, all around the world, but a focus on Asia, and we did some publications about it. So I hope that helps and hopes that stimulates you to upload some projects as well, because that's of course mostly online. But there's, last but not least, also Climate Scan in practice, and that is linked to Climate Cafe. And maybe you heard of it. If you're in research, there are a lot of publications about it. You can find here. You can tap into it's all open source, so you can find more inspiration about it. But basically, it's, and I focus now on Asia again, platform and tools all around the world. It's learning by doing methodology. We go out in the field and research, for example, floating urbanization or green infrastructure. And then we use all that new knowledge to share with you on a Climate Cafe itself, if you participate. But you can also find that on Climate Scan. And then Climate Cafe, what is it? Well, this is all in Asia, for example. So a lot of times we go out, do measurements and disseminate that knowledge, as been said. But on climatecafe.nl, you can find climate cafes in Semarang or Surabaya or anywhere. And the basis again is analyzing, ambition, and action. And I find that action, being from applied sciences, the very important part, because you can form your analyzing during action, as you can see here. You can find your ambition with your stakeholders that are involved with the Climate Cafe. And that makes this a quite nice learning experience that we can do together on an international level, as you've seen there. And then we use it for, of course, books like this, because that's what researchers or professors do. They write a lot of articles, but climate adaptation is all about analyzing different things and answering questions from you. One of the questions, that's the last one, and then I'm going to leave. One of the questions was, for example, fine, you show a lot of green infrastructure from Europe, but don't forget it's a different situation in Asia. If we store water, what will happen to malaria and dengue, etc.? Well, that's a very important question. We analyzed, of course, green infrastructure in Europe and seeing if there are risks, in this case, for example, for different incubation of mosquitoes. And that taps into guidelines. So we do research on green infrastructure to make sure that it will empty within like 7 days. If it's empty within 5 to 7 days, mosquitoes get no chance to basically distribute their loved ones, so to say, and cause diseases. So, and that's very practical, and that's the I think the level of climate adaptation, the implementation of green infrastructure and floating infrastructure should be. Don't go too fast. Answer questions. Build a network, as you saw in all the pictures. I think we have gone a long way. So, take home messages. I know it was fast, a lot of info, but I would say let's get to work. Let's go to climate action. I think I showed we share challenges, very major challenges, but sometimes small solutions could be already part of it. And if you have a lot of them, it builds up to a very big solution strategy, so to say. Analyze, ambition, and action. More info. I showed you a lot, I think, on everything that we're gonna do this Congress as well. It's about dissemination, it's about communication, and I'm very glad, of course, that this conference can contribute a lot to this. And of course, I reviewed some papers, read a lot of papers, saw some presentations that are coming, so I'm very excited about it. And more info. Can you participate? Yes. Share your knowledge. Find us. Find us on the Climate Cafe. Find us on the Climate Scan. And I really hope that we see you there. And I'm going to leave it at this. And maybe there are some questions from you guys to answer. So thanks a lot and see you soon.
Okay, thank you very much, Mr. Flores. Give some applause for Mr. Flores. I think it's very interesting presentation, how we can adapt for the climate change and how we can cooperate each other, just not for one country, but multi-country. And now the INFINID talk will begin. I will introduce Dr. Rinda Karuninasari. She is a lecturer at Sultan Agung Islamic University, Semarang. She's graduate from for the doctoral from Parahyangan Catholic University in Bandung. She is also director of PT RK Consultant Engineering. She's an expert in geotechnical engineering, of course. She lives in Kabupaten Bogor, West Java, Indonesia. And now, Dr. Rinda Karuninasari will presenting case histories of recent embankment construction on sediment and residual soil. And now, Dr. Rinda Karuninasari, the time is yours. Don't forget to write your question in the chat box, and then Mr. Flores and Dr. Rinda will answer it. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, honorable ladies and gentlemen. First of all, I like to express my gratitude for the INFINID 2021 committee to give me the opportunity to share my experience of the geotechnical problem that we face at design and construction. My name is Rinda Karinasari. I am a lecturer at Civil Engineering Faculty of UNISSULA, and I'm also work as geotechnical consultant. Many of my work is to build an embankment. Today, I like to present the case stories of recent embankment and construction built in sediment and residual soil. I will start my presentation. Okay. In recent years, infrastructure projects were constructed in Indonesia massively. New cases of construction were encountered with many varieties of soil. Sediment soil were dealt at north of Java and South Sumatra project. Embankment were constructed above a deep soft soil with high compressibility. And tropical volcanic residual soil at a high latitude also have to deal with at the West Java project. The many variability of residual soil with different parent rock, different path of weathering process were encountered. Such constraint as high water content during construction also have to solve. The geology of the site also has to deal with and learn from these cases were very interesting process. Whether it is good performance of embankment or fail of the embankment is a lesson very valuable. These case stories remind that characteristic of the soil is still very new ground with many parameters of it have not being recognized or defined yet. So if we talk about design and construct embankment, there is 9 important point, I think. The first is the purpose of embankment. Okay, and the second is geology of the site. We know in Indonesia, we call it a very active tectonic site. And the third is the characteristic of soil and rock. Residual soil is soil weathered from parent rock and still remain in its position, while the sediment soil is the soil already transported by body of water and then sedimented at lower ground. And the fourth is design criteria. In example, in toll road, the design criteria for the settlement after construction is have to limit it to 10 centimeter over 10 years. That is the design criteria. And the fifth, stage construction and compaction. You know, different state construction at the site, the result is different state of soil. And the sixth is the soil and rock parameter investigation. The seventh is analysis of embankment slope stability, also bearing capacity. The eighth is instrumentation of embankment slope stability, instrumentation of settlement, and the last is the case history of embankment. Is it new embankment or already at some time before embankment? That is the case history of embankment we have to know. So today I would like to present 4 cases. The first is vacuum consolidation cases and how to review its performance. The project is at South Sumatra and East Kalimantan project. And the second is rigid inclusion soil improvement at Central Java Toll project. And the third is the effect of climate at the construction of hike embankment. It is at the West Java Toll project case. The fourth is the anticipated the liquefaction at the coastal area embankment. The project is a circuit at South Lombok project. This is the first case where vacuum consolidation were conducted. The project is at South Sumatra Toll project. We see here the photo of the project at the initial stage, where is the project will construct mainly above the swamp area. This is during the first field of embalmment. The black sheet is the geotextile, which cover the geomembrane from the field embalmment above. The vacuum process were done until the field embalmment were finished. And we can see here, this is the configuration of vacuum during construction. We here see many monitoring tools. At the center line, a vacuum gauge and a settlement plate and a piezometer were installed. At the left and the right side, another two of settlement plate were installed. At the ground level, you see here at the left side, inclinometer were installed to see the horizontal deformation. In case there is instability happen at the slope, also to define if the vacuum force were delivered to the system. To define the state of the soil below the embankment, we then use the CPTU. So this project is already done and now is at operation level, but there is some defect at the pavement, and a few settlement also happen at the site. So to define the state of the soil below the embankment, we then use the CPTU. The CPTU is a concentration test with pore water pressure measurement. You see the white line at the cone. It is the pore stone where pore water pressure measurement were done. From the result of pore water measurement, then we could define if the soil being under consolidated normally or over consolidated. And then after we know the state of the soil, we then calculated the remain settlement after the test for disembalmment. This curve were introduced by Raharjo and Setionegoro at 2015. It is the dissertation of Mrs. Setionegoro. It is divide the soil from certain BQ ratio as it is under consolidated or over consolidated. The BQ parameter is the ratio between delta of excess pore pressure to hydraulic pore pressure with GT minus sigma V accent, which KT is consistent corrected by area factor. Sigma V accent is effective stress. We have here, if we have a BQ equal to 0.7, then the OCR is equal to 1. At the left of the curve is under consolidated zone. So we have a degree of consolidation, U%, and at the right of the curve, we have over consolidated zone and OCR number. After we have the state of the soil, then we can calculate the settlement. This is a consolidation curve where we have PC accent value to define the zone where there is recompression and virgin of first time consolidation. If we have almost the same increase in stress, here we delta sigma 1, we draw delta sigma 1 here and delta sigma 2. At recompression zone, we have a small settlement, which is delta H1. Compared to the normally or first time consolidation zone, the settlement become delta H2. So basically, if we have an OCR zone, then we will expect it small as settlement after the test. But if the zone is under consolidated or normally consolidated, we will expect a large settlement. Fortunately, at this project, almost all soil improvement zones were classified as over consolidated. Only few areas remain still in under consolidated state. This is another example we have here. This is at the adjacent project, which is a valuable case to learn. This is a vacuum area near a bridge abutment. The bridge is Q. During a hectic situation at the project, the bridge and the vacuum consolidation were done simultaneously. It is left behind an area of transition from the vacuum area and the abutment bridge. After the project is finished, a large settlement occurs in this area. So the lesson learned from this, that is for vacuum consolidation method, which done simultaneously with structure, there is always a transition zone between a structure and embankment. And this transition zone have to be anticipated. This is the CPTU profile below the bridge girder in front of the abutment. From the Robertson graph, you see, this is the Robertson graph. You see that most of the point results were at the left of the diagonal normally consolidated line. You see here the normally consolidated line at the diagonal. So the result is below or at the left of those graph, those line. And it means that the soil below the girder were at initially conditioned. And this is the CPTU profile at the vacuum consolidation. You can see here. We can see here that the most of the point were at the right of the normally consolidated line, which means that the vacuum process were already conducted a stress history to the soil below the embankment. Okay, so that is we learn from this case that we can define the state of the soil with CPTU. And this is another project. This is a toll project in East Kalimantan. This is one of the section. A section of toll road where constructed of a swim area. This is the contour. You can see a certain line were at two of a hill here. And at East Kalimantan, a layer of coal usually will found almost at any place. When the project asked us to review the soil improvement were PVD preloading, which at the moment many fail of the slope will happen. You see the red line, there's the failure line. This is the photo of that moment when we were called to review the case. Already so many failure. At first, we just see that it is a fail of slope stability and bearing capacity of the soil due to the soil improvement, which is being chosen, which is PVD preloading. As you know, the preloading will make the state of the soil at very low due to high pore water pressure induced. But then we see this kind of stratification of the soil below one of the cross. Then we inform the owner that with only a soil improvement for the soft soil at that time, vacuum consolidation was chosen. At the end of the project, we will still have to dealing with this inclination of stratification. So that's then happen. You see, this is the inclometer. this is before the bore piling of the side of the slope. Yeah, we see this kind of inclinometer. As you can see, the inclinometer not behave like a pore pressure dissipation during construction. Usually, a pore pressure dissipation will give a letter D, or maybe some say a pregnant curve. So this kind of graph is not caused by pore pressure dissipation, but this kind of graph is caused by a slight layer movement. After installation of bore pile, another inclinometer was stopped at a certain point here, which is at 30 millimeter, indicate that the movement was stopped by the bore pile. Okay, we then go to the case number 2. It is a rigid inclusion soil improvement at Central Java Top project. This is the soil improvement at transition zone between a vacuum consolidation soil improvement and structure or bridge abutment. The site is near Pekalongan City at Central Java. You see the white zone. It is geotextile surrounded by the vacuum zone. Fill embankment were at initial stage. The structure already stand up, and the rigid inclusion, or we usually say it KGM, column growth modular, also constructed at the same time. This is the layout of the full bridge. It has 4 span. And this is the configuration of the grid. It is 2 times 2 meter. The length of the improvement at each side is 30 meter. This is the cross section like this. What is special for this rigid inclusion improvement is the embankment of quite high at around 12 meter. Bearing capacity will increase by the rigid inclusion, but the concern that lateral capacity is not enough will increase. So at the rigid inclusion at the left and the right side, at the blue square, a steel reinforcement were installed. This is the configuration of the monitor tools at this side. Settlement plate and piezometer was set up at the center line. And inclinometer was set up at the ground level next to the 2 of the embankment. You see here the embankment were constructed at fast rate right here, almost 3.25 meter at 6 days. The settlement will also monitored. And this is the inclinometer results, which show us that no lateral movement were big enough at the ground soil, and the embankment were in stable condition. So this rigid inclusion can stand to slope stability. This is the embankment at the same level with the structure, and it's been operated as an alternative route during Idul Fitri season at the year of 2018. Okay, this is also the photo. And the third case is the impact of the climate on high embankment construction. This project is in West Java area. It is next to the Bogor city, which we know were famous as a rain city. The intensity of the rain is high, as is in this report of climatology board. In this project, we also encounter with residual soil, specifically the tropical volcanic residual soil. As seen in this data, the highest rainfall not only in the December, but also in August. This data from the year of 2016 through to the year of 2018, the rain data has no pattern. Almost all the year has been at high intensity of rainfall. The pattern of rainfall make the quarry soil of the Ekbaman, which come from nearby area, were in wet zone. Wet zone mean difficult to compact it at optimum water content. Since the location is in hilly mountaineering area, the water table is far below the ground. Usually, this become an advantage because suction is excess. But because of the rainfall intensity, the suction at the ground become lower. In this photo, we will measure the suction at site with jet field tensiometer. The suction measured at the site is as follow, which maximum is at 18 kPa. This is the profile of suction that we have been measured at Padalarang near Bandung when I conducted my dissertation. It is around 40 kPa at noon measured by jet field tensiometer. So at Bogor area, the ground suction is lower. This is the Vela envelope for unsaturated soil, which introduced the third axis, which is a suction axis, where the higher the suction, the Vela envelope become larger, which means the strength of the soil increase. Raharjo and Fredland suggest the value of PB to define the increase of strength, which significantly high at the start of increasing matrix suction. In my research done by unsaturated triaxial test, the VP is around equal to 1/3 or 2/3 of the effective friction angle. Here, the friction angle is 22 degree and VB is around 14 to 16 degree. So this empirical equation were assumed when we done the numerical modeling of the Bogor toll road. First, we derive the SWCC from grain size distribution of soil as seen here. This is the grain size. This is the SWCC or soil water characteristic curve from the grain size distribution to the type of the soil and the comparison between the measurement of suction at site with jet potentiometer. Here you see maximum is at 18. Because there is no measurement of volumetric water content, we here derive it from gravimetric water content, which may be not accurate. At this level of suction, it should be on the maximum volume water content state or saturated. So it has to be at the highest level of volume water content. So how is this saturated soil have to be compacted for the field of embalmment is the problem. And we then propose to layering the field with sand and gravel. This is numerical embalmment model. But done by consideration of the rainfall data, we calculated the embankment in December in example. So during the field, the rain were put to the model in accordance to the construction state. The yellow color is the layer of sand and gravel that we put in if the intensity of rainfall is high. So the amount of sand and gravel layer were dictated by the intensity of the rainfall data. And this is the safety factor of the embankment during the stage of construction. It was not a linear since it is dictated by rainfall intensity, not only by the height of the embankment. At long time rainfall induced instability, this is the safety factor due to rainfall return period from 20 years to 100 years. That is the safety factor. So we came to the fourth case. It is an embankment built to anticipate the liquefaction. The project is at south of Lombok. Lombok is an area that prone to earthquake. This is the soil profile, which we have loose sand from ground level to minus 6.5 meter, and another layer deeper, which is at 11 to 13 from ground. And this is the layout of the circuit. In liquefaction term, we know two parameters. The first is the resistance of liquefaction, which is called CRR, or cyclic resistance ratio. It is the capacity of a profile of soil not to liquefy. And the second is cyclic stress ratio, or CSR, which is the ratio of the stress in soil during the earthquake. During earthquake, the pore water pressure increase and then the effective stress decrease. CSR at the field is the same as CRR. And the safety factor defined as the ratio of CRR divided by CSR. So you know the capacity divided by the force. So to anticipate the liquefaction, we can do one of three schemes. First, to increase strength, which is increase the CRR. Or the second is to decrease CSR. Or the third is to decrease excess pore pressure with drainage. Okay. For the first scheme, we can do the compaction of the loose soil, which means increase the CRR. The second scheme, we can increase the stiffness of the soil. So the stress that happen during earthquake will reduce, which means decrease of CSR. Number one, compaction is increase CRR. Number two, drainage is the third scheme. Number three, reduction of stress. It is means a decrease of CSR. And number four is also decrease of CSR, the confinement. In this project, since a layer of loose sand were also found in deep layer, we propose rigid inclusion to mitigate the liquefaction. This is the comparison of CSR. If we install rigid inclusion, the CSR become lower with the install of the rigid inclusion from without rigid inclusion is 2.148, and after install of rigid inclusion it is become 0.795. So it means safety factor increase. This is the photo of the construction of rigid inclusion at the site. You see, it is a quite fast process because one point it's only take 10 minutes to install the rigid inclusion. Something in the quote good will happen just after the completion of the embankment. Earthquake strike, and we can see many small seepage drop of water from underground. The seepage point indicate that the increase of excess pore pressure will occur during earthquake, but the system already have stiffness and the stress decrease. That concludes my presentation, in which we learn many lessons from what happened during design and construction. Thank you for your attention. Further discussion will certainly very welcome. Waalaikumsalam warahmatullahi wabarakatuh.
Dr. Rinda Karinasari. I hope you all enjoy this amazing presentation because she has a lot of experience in many projects, especially in toll road in Indonesia. And now, Mrs. Rinda, hello. Please, the mic off. Voice of Miss Rinda. Hello, Miss Rinda.
Okay.
Okay, thank you, Miss Rinda. There are two questions to Miss Rinda before before Floris will answer the question. First from Miss Hasti Widya Samratri and then followed by Heri Awan Susanto. First question is based on your experience, because you have a lot of experience in the project or in the embankment on etc. Which area is the most difficult to do based on its soil or geotechnical characteristic, and why? And then question number 2 is from Heri Awan Susanto. What's your recommendation if we deal with muddy soil in road construction? Do enough to fill with gravel or replace it? Or replace it with another new soil. Please, Ms. Linda, you can answer the both questions.
Okay, thank you, Pak Ari. Okay, maybe I just answer the question from Mrs. Hasti. With soil, I think every soil has advantage or difficulties to make an embankment. I usually see the soil is like a patient because it is natural made. So it is difficult to choose which one is very difficult, but every soil has a characteristic, and we have to deal the project with its characteristic. That is Mrs. Hasti. What I think about the soil. So we have a sediment soil. We have a large compression in sediment soil, but we can overcome it. Maybe residual soil is stiff, but there is something different in residual soil, like the mineral and how much water can contain in that soil. So it is also difficult to deal with. That is Mrs. Hasti. Okay, for Pak Heri, if we have a muddy pavement, yes, we have many options, Pak Heri. First, we have to just dry it. Just you have to dry it. You wait for another couple of days to have it dry. And the second is you have to have a additive, many additive here is available. So you have to conduct a research on that soil and mix it with any other additive. And do you have a water content lesser than the natural at the site? And the third, I think, with what I presented there with and with sand and gravel, if you want to make the project of at very fast pace, that is maybe my answer, Pak Ari.
I think it's very comprehensive answer from you. And then the third question from Wahyu Ningsih, BPPCN Central Java. How to overcome liquefaction on subsoil that is submerged in water, such as in the area of the planned construction of the Semarang Demak toll road? Please, Ms. Rinda.
Okay, yes. First of all, liquefaction happen only below the water table, I think. So if you have loose sand below water table, so that's maybe very prone to liquefaction. So if you have that problem, I think that's the third scheme that I explained before. The second is give it a strength. So you increase the capacity, and the second decrease the stress when earthquake happen. So you decrease the stress when it's happened. And the third is go for drainage. So the drainage system will be very fast, excess pore water pressure, not increase enough until effective stress very low or decrease and give it as liquefaction. You have those three schemes, and what is acceptable for your problem, maybe you can consider this scheme. You have a compaction, you have rigid inclusion, or you have a stone column, or maybe you just install the drainage. That is many scheme you can choose for that problem. Okay. This is Pa Harry.
Okay, thank you, Miss Rinda. Okay, welcome to Infinite, Prof. Floris. Could you hear us? Okay. Hello, Mr. Floris. How are you? Fine? Yeah, mic, the mic still mute.
Oh.
Okay. Is it clear to hear us?
Yes.
Okay, nice batik, Prof. Floris.
Okay. Yeah. Good morning, everyone.
Yeah,
From the Netherlands.
okay.
Yes.
There is one question for you, Mr. Floris, from Heri
Okay.
Awan Susanto. The question is how we can prove that climate change and climate cafe can reduce or minimize the climate change effect. Please, Mr. Floris.
Yes, that's a very good question indeed. Well, some of these tools that I showed are around for some time. Climate, for example, 2014, and Climate Cafe is already used some years. And we actually did the research as well, what the impact is of these tools. So just to start with Climate Scan, and now it's being used with over 1,000 registered users. Of course, a lot of people watch every day to Climate Scan, about more than 100. And we did some interviews with the people that are actually using these tools, and well, it raised the awareness, and it contributed to capacity building. And that's of course not a very exact number that you can give because it's mostly social science, but it led to reproduction of a lot of innovations. So that's one with Climate Scan. And Climate Scan is only online. So Climate Cafe is an action that we did in Indonesia and many parts of the world, so to say. There you can see that we did actions in that Climate Cafe week. So we actually made floating islands, for example, in the Philippines, or we dug swales in the Netherlands. So that was really concrete, that you can see that it had an impact on people, and that as a wise man said, you can show me, I will learn, but if you involve me, I will actually be a participant of, for example, climate action. So I hope that that answers your question.
Okay, thank you, Mr. Forrest. Okay, for the all participants, is there any questions? You can write it in chat box. For Prof. Forrest and Dr. Inda, because both of them is the expertise in their field. Or maybe Mr. Forrest, you have some explanation live, because before we just meet you in the video. I think it's very touching when you can explain some ideas about the climate change, how we deal with it. Please, Mr. Forrest.
Okay, thank you so much. And sorry that I'm a bit late. It's it's 5 o'clock in the morning, and I had some startup problems. So very sorry. Yeah, what can I say? Live. I was maybe I can as you saw the video, of course, and I hope that was a bit clear. Maybe I can amuse you, so to say. Let me share my screen if that's possible, and I think I am doing that now. I hope you can see the map. So if you would go, because I showed you only some tools that you can work with, and this is one of those tools. You just go to climatescan.com. In this case, wait, that's always let's go to NL then. You go to Climate Scan and you see a large map where you can find projects all around the world. And what is great about it, of course, it's set up in Europe. You can see more than 4,000 projects here, but all around the world it's getting to 8,000. I will do not too much because maybe the interconnection is cool. What I like about this, of course, most of you are in Indonesia and Malaysia today. You can find a lot of different projects just by going there. And being some of you are in Semarang or maybe in Jakarta or in Malaysia, you can just go there and click on points where you want to go, and you can see floating houses. You can see some of the projects that you saw in the video just by going there, and that makes it, I think, a lot nicer. So just to give you one example, here in the airport, for example, where I start, is part floating, what they call it. And you can already see some projects here that are related to sometimes it's just infiltration by biopori or that kind of thing. So that is maybe one example that you can find. Also, Climate Cafe, the other tool that was in the video, just to show you where you can find information. For some reason, it doesn't work. Here, Climate Cafe. If you go to news, for example, you can see all the climate cafes that have been held. And there's one rule with Climate Cafe: it has to have a tangible output. So you can go to Gothenburg in Sweden. You can go to every place where you want to find information, and there are over 50 already. So even China, Spawn Cities, probably you heard of it. There's some knowledge exchange about it. And if you go to some older posts, so before COVID, you can find a lot in Asia as well, where we did things. In Africa, for example, we did river scans, so you can learn about how we did different things. This is Manila, for example. So there's a lot where you can find, and I don't want to make too much time, of course, but in this case, this is really about knowledge exchange. This is really about you finding information of all these projects about people that went to Indonesia and Malaysia and all over the world, and can find what they did with short videos, with guidance. And I really hope that help you guys and us as well, because I found it very learningful to see a floating library, for example, in Semarang in this case. So let's exchange our knowledge. That would be my message, and I hope these tools can help you with this.
Okay, Mr. Forrest.
Yeah.
There is a question from Miss Mila Carmila. It's about climate change. How do you think the community engagement to solve problem and impact of climate change?
Yeah, that's another very good question. Sometimes, you have top down. I work at the Global Center of Adaptation. That's really top down. It's with politicians. But for most of us, like me as well, you don't reach the level of where climate change should be. For example, that's really on community level. That's really bottom up. And that's what I like the most. That's applied science that is getting contact with people and change their minds, so to say. It's about behavior change. And in communities that I was involved with, a lot of people think the problem is so big. Huge storms. What can I contribute to that? How am I just one player in a million people that should be involved? And then sometimes, in this case, how it changes is that I show a map, for example, like Climate Scan. You see in a city, I live near Amsterdam, the capital of the Netherlands. You see already 250 points of small things that happened by communities. Sometimes it's a green roof that a person made themselves, or they made a small swale, or they did urban farming. And if you see 250 points in a city, and I show it to them, that they're just a part of that, and this is just the beginning. It will be 500 maybe in 2 years, and it will be 1,000 in 5 years. Then you really make a connection, because you see the city is more greener, and that makes the three threats that we fear the most around the world, but specifically in the Netherlands also, is floodings. So we have to give more space for water. We have drought, even in a wet country that a lot of countries in the world are wet. We need to store that water, but also infiltrate the water, because groundwater levels are diminishing, and we have to recharge them, for example. And the third one is heat stress, and green helps with heat stress. It's the shading, but it's also the green helping that. For those three things, greening cities is very, very important. And if you see 250 points getting 500 points and bigger, you can see that communities believe that they are part of something bigger. And that is very inspiring for me to see, because that will change people. That will show that there are part of this movement, basically, and change the world. So I hope that answers the questions about how a community can really engage and, of course, believe in what they are doing is very important.
Okay, thank you, Prof. Floris. I think there is no more questions for Prof. Floris and Mrs. Rinda. Okay. Thank you again, Prof. Floris Bogart and Dr. Rinda Karinasari. for answering all of the questions and for the great presentation. It was a pleasure to have you with us. The conclusion of today, the main thing that we can learn from the both of them, from the Prof. Floris Bogart and Dr. Rinda Karnasari, is as an engineer, we have to deal in any condition. Actually, today we have to deal with the climate change, how we can solve it, how we can design it to solve the problem. It's depend the situation. So, as an engineer, we have to more adaptable with the climate change. So this concludes the keynote speech and invited talk of Infinite 2021. Thank you all for attending. We hope you have learned and enjoyed this session. And now I will be giving the session to the Master of Ceremony, Miss Indah. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Can give applause
Thank you.
both to the speaker and the moderator. Thank you very much again, Mr. Adi Sentani and the two great speakers today who already shared their expertise. Yes, ladies and gentlemen, the whole agenda of the opening ceremony today is coming to the end. Now we are about to have the parallel session of INFINID 2021. This parallel session divided into 3 rooms. Room A for ICCDA within the theme Flood Management and Technology, which will be chaired by Dr. Ahmad Sahri. And then room B for GEOTROPIKA within the theme Soft Soil Engineering and Geohazard, which will be chaired by Dr. Mila Carmila. And the last room C for ICHITRA within the theme Traffic and Highway Material, which will be chaired by Dr. Prabowo Setiawan. And all participants and presenters, you may enter the room through the given link by the committee. The link can be downloaded in the INFINID 2021 website or in the chat box room. It will be informed later. Okay. Once again, I kindly reminding, please fill up the attendance list, which will be given in the chat box by the end of the presentation in each room. Okay, ladies and gentlemen, we would like to express our great appreciation for all main organizer, collaborators, sponsorship committee, participants, and presenters here. Thank you very much for your attention. Hope this conference will be very beneficial for all of us. And see you tomorrow in the second day of INFINID 2021. Have a nice conference. Stay safe, stay healthy, and always happy. Wassalamualaikum warahmatullahi wabarakatuh.
The world is in motion. By the year 2050, there'll be more than 9 billion people on the planet Earth. 70% of them will be living in cities, and 80% of the products they consume will not be made or grown in their own country. So how do we make sure that the world stays in motion in the future? by taking a closer look at traffic and transportation as a whole, and developing integrated intermodal solutions for passenger transport and freight transportation, real-time solutions. After all, the world of tomorrow is networked. To ensure that goods arrive precisely where and when they are needed, routes must be strategically planned. With optimization tools from PTV, logistics operators can keep an eye on fleet efficiency and costs and always pick the most environmentally friendly route. To ensure that all road and rail users are treated fairly, cities and traffic planners must design urban infrastructures with maximum attention to details. This is where the planning and simulation tools from PTV can help. Will I be in time to catch the connecting service? What will the traffic situation be like in 10 minutes from now? Which is the quickest way to get to the city centre? PTV has the answers with innovative software solutions and consulting services for passenger transport and commercial carriers. From planning to implementation, we keep the world of the future in motion. Because we are the mind of movement.
Evolution is natural, a never-ending process of continuous change. Change that makes people and ideas even more successful, stronger, faster, smarter. Change that leaves the competition behind. Evolution is when pioneers set yet newer standards, raise the bar yet again. Evolution is when the best get even better. For Anton Parr, evolution means the next defining step in rheometry. The MCR Evolution Rheometer Series, consequent thinking and rethinking, decades of experience as the world market leader. More than 10,000 happy customers around the globe. Their feedback, the foundation of our new generation of rheometers. The result? A rheometer lineup incomparable to any other brand on the market. 15 rheometers, more than 200 accessories. The gold standard for custom rheological solutions for every application. The gold standard set by Anton Parr. MCR 302 and 702 are benchmarks in their segments. MCR 302 Evolution is the world's best-selling rheometer made even better. Optimized air-bearing EC drive, 40% faster system electronics, improved thermal management, and one-hand coupling, ingredients for success in challenging environments. MCR 702 Evolution Multi-Drive boasts the same advancements as the 302, plus the power of 2 drive units for the most sophisticated rheological research. Anton Parr was already pushing the limits in rheometry back when we invented the first EC permanent magnet synchronous motor. A new trimming mirror, a whole array of other features set the standard in instrument usability. The temperature range of minus 160 degrees Celsius to 1000 degrees Celsius is unique on the market and even allows the analysis of molten glass. Our Rio Compass software provides a spectrum of possibilities with countless measurement modes, 200 plus predefined templates, and top-level CFR 21 Part 11 compliance. 97% of all critical mechanical parts are manufactured in Austria in our in-house production facility. That means we also challenge the status quo of high-tech production chains. Evolution is a process where small, continuous improvements lead to a superior product. MCR was already the best. All the Evolution series means is the best just got better again.
Changes for some companies may be frightening. However, when the company manages to control fear, then it will be a tremendous energy to rise again. And Wika believes that. Being good is not enough. Wika must be great. Wika has represented itself as a state-owned enterprise, SOE, that first entered the foreign market before other contracting companies. This shows that Wika once again not only present, but help to carve a long history of development of Indonesia. Wika continues to try to find a new identity, which is better and more competitive and does not hesitate to reposition itself as a SOE that is ready to compete in the international arena. Wika believes that just being a leading company in the country is not enough. Then construction projects overseas are also rich. In addition, in the context of benchmarking, Wika wants to see and learn how the big companies overseas work. With these efforts, Wika expected them to be able to increase the network as well as strategic partners for strategic work at domestic and overseas. In developing overseas markets, Wika has done selective marketing strategies gradually. Wika enters a strategic in certain countries that are more competitive advantage compared to other countries. Wika focuses on international markets that have been controlled by itself. So far, Wika has reached the construction market in Africa, Southeast Asia, and has entered the Middle East market. In carrying out a project, Wika emphasized the concept of cost, quality, and time. It means we have been trying to make every project that we work on has superior quality, without light efficiency and effectiveness aspects. This is what makes us able to survive in the competition in the construction sector today. These values are unique and provide a strong and consistent platform to encourage every Wika resource in winning the competition, not only in the domestic market, but also in the international market.